In this video, we are going to learn how we can describe graphs, because describing is a pretty important process that we have to understand how to answer. Let's say I show you this graph, velocity graph. How would you describe it? Maybe you might say, oh miss, at first it is a flat here and then it go down like that. But what is flat here and go down like that? Cannot. You have to use specific terms to describe specific graphs. What if I change this graph? What if instead of go down, I say go down like this? Curve wall also go down wall. Or what if I say, oh, the thing go down like this? Also going down wall. But what the shape different? How you describe? What's the difference? So that's why we gotta know how to describe these graphs. Now let's say we start off with something against time. Maybe let's say velocity. Every graph you look at, you must check the axis first. What is this? Velocity graph, V for velocity. Alright. And let's say I want to make this graph say velocity is increasing. Okay, so I'm gonna, whatever I describe, I'm gonna start with this. Velocity is increasing. ... And what are the graphs I can draw? The first one is if it's a straight line. This is what we call a straight line, but you cannot say velocity is increasing in a straight line. No, we want to say velocity is increasing at, we need to fill in the blank. Here we're gonna say at a constant rate. Rate is pretty much referring to gradient. That's the first one. But what else can we draw? Like just now we saw, you could have a curve, maybe something like this, where it goes from low and goes boop. Okay, not very nice curve, but yeah, something like that. Also increasing. So I'm going to stick to my right side. Velocity is increasing, but at a different rate now. We are going to say at a decreasing rate. Decreasing rate. It's still increasing, but increasing slower. And the rate here, reminder, you can refer that to as the gradient. How's the gradient changing? That's what we can say. What else do we have that was missing? The other curve. What if I say now velocity is increasing, but in this strange manner? Okay lah, my graph is a bit out of shape. It look like a leaf now. So you can say again on the right side, all these are velocity increasing at a what rate? So here we are going to say at a increasing rate. Increasing rate. End of the day, they all increase up to, let's give a value. Let's say 40 meters per second. They all reach 40. They're all increasing, but at different rates. And that's the difference to tell between these three. Now you might be wondering, Miss, what if we look at the negative part of the graph? How will we describe that? So one thing to know about velocity graphs is these are called vectors. So if this part is in the positive zone, this whole thing is in the positive zone, that means your velocity is all increasing in a certain direction. For example, I need to define, okay, I say the car or a box is moving to the right at a certain velocity, and this is going to be positive direction. Okay, so all positive, right? All this graph in the positive zone. So all this car moving to the right. What about the negative side? Let me draw a line down. If you see this, would you say velocity is increasing? You say, but miss, wait, the graph go down. Wait, this is in the negative. You go from 0 all the way down to, what, that's giving negative 40. Increase or not? Yes, you go faster from 0 to 40. But why got negative sign one? Oh, that is because now your car in the negative. So your velocity is now going to the left. And this we define as negative. So the sign, positive or negative, you choose one, okay? So this one is going to be velocity is increasing at a constant rate also. So I'm going to write there. I'm going to try my best to write in a nice manner. So increasing at a constant rate. Okay, now we draw the blue color one. Increasing at a decreasing rate. So at first, wow, increase very fast. Then after that, slow down a bit. Then slowly, okay lah, reach 40 already, flatten out. So it's increasing at a decreasing rate. So that's going to be this one. somehow hard to write. So velocity is increasing. We're still talking about increasing from 0 to 40 at a decreasing rate. There we go. Gradient is the rate, remember? And lastly, our favorite orange one, increase to 0 to 40, but increase faster and faster. So you're going to look like that. Yeah, why so out of shape one? I try again. There, I changed the shape. So this is going to be increasing at a increasing rate. A increasing rate. All right. Now, if there's a negative sign, I will also mention increasing. So the full sentence is, if I want to say for the blue color one, maybe example I will say velocity is increasing from 0 to 40 meter per second at then I talk about the gradient. Is it constant or is it changing? Oh, changing. Okay, so I say at a decreasing rate. And oftentimes, when there's a change in sign, let's say from positive, suddenly you go to the negative. So now your graph is in the negative region. Oh, change direction already. So this positive, negative tells you the direction. So we got to say also in the opposite direction. In the opposite direction. That is the best way you can explain, say, this graph. Okay, so whenever you see any graph, remember, talk about increasing or decreasing first. Number one on the right side, you see the number, is it going from 0 to 40 or 0 negative 40, both also increasing. Then you talk about the curve. Then if you need to mention opposite direction, you talk about the opposite direction. Okay, if this is increasing, then what is a decreasing? Let's do another one. Again, you can put any graph you want. Y, A, B, C, D, velocity, acceleration. But I'm going to stick with velocity just for consistency, so you can see the similarity across all three graphs. Now we want to draw graphs where your velocity is decreasing. So all these sentences that you describe must start with number 2. Velocity is decreasing. But also you must mention at what rate? At a constant rate, at a what? So this is all the graph that is decreasing. Let's say we start off at 40. You want to go to 0. So how would you draw it? Draw a line. Yeah, my line a bit off. Okay, let me change this 40. Okay, 40 is up there. So this is decreasing at what rate? You see straight line, right? Don't say decreasing in the straight line. No. You say decreasing at a constant rate. From 40 to 0. AKA slow down. Decreasing means slow down. Then we have the other ones. Decreasing at a decreasing rate. So you something like this. Almost there. Okay. So decreasing at a decreasing rate. What other ways can we decrease? Increasing rate. Okay, we do the third one. At first very slow. Then suddenly, wow, decrease so fast. Break. Skirt. Then this one is called velocity is decreasing from 40 to 0 at a increasing rate. Increasing rate. Okay, there we go. So that's all the case from decreasing from 40 to 0 meters per second or whatever acceleration. Can you do the opposite? Can, why not? But wait, let's draw this first. All this is in the positive region of the graph. So it's all decreasing in one direction. So maybe I can say, oh, here's a box. It is moving to the right. Maybe I choose to the right as positive velocity. But it is moving slower and slower, slowing down as it moves to the right. Pew, 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 pew. Okay. Now, if you want to slow it down but moving the opposite direction, you go to the negative graph. Let's say like this. And we go from negative 40 all the way down to 0. So it's kind of like saying, oh, you have a box here. It's moving to the left, yes, with some velocity. But since negative 4, we say to the left, and this is also slowing down. Slowing as it flies to the left. This is velocity is decreasing at a constant rate. And also, decreasing rate, how to draw? Decreasing rate is here. At first, you drop a lot, then suddenly you slowly reach 0. This is velocity is decreasing, still going from 40 to 0, 40 to 0, but at a decreasing rate in the opposite direction. Oh yeah, all this must talk about opposite direction, okay? Decreasing rate in the opposite, I just write here opposite to remind ourselves. Constant rate also opposite direction. Opposite. Last one. At first you slow down a bit. Suddenly you see a rabbit and you slam the brakes. And then you drop down to 0. Phew. This one is velocity is decreasing, but at an increasing rate. So at a increasing rate in the opposite direction. All these are all opposite direction. Because why? We are now in the negative part of the graph. So it's opposite to wherever you were moving in the first place. So once again, let's write an example sentence. What if I want to describe, let's say, the blue graph? So example, I can talk about it by saying, let's look at the one down there. Velocity, or whatever graph, acceleration, then you say acceleration. Velocity is decreasing at a decreasing rate. Then must say in the opposite direction. So in the opposite direction, because you are in the negative part of the graph for the one down here. Okay, is there anything else we missed? We got go increasing. Oh, where's number 1? Number 1 is velocity is increasing. Number 2, velocity is decreasing. Oh, constant. Okay, the last one. So what if you have a graph that is constant? How would it look like? And how will we describe it? So if you have a graph that is a straight line that looks something like this. Steady. This one, always at 40. Okay, then you just say velocity, or whatever graph that is. If it's acceleration, you say acceleration graph. Velocity is constant. So one possible graph you can see is constant. Constant value at 40. How about the other one, negative God? God, you just draw another line here. This one is negative 40. If say meter per second lah. So the first one is, this one don't have rate. It's just constant. There's no rate, so no need to talk about the rate. All we need to talk about though is the positive part and the negative part and what that means. So positive part can mean velocity or whatever graph you fill in the blank is constant in the forward or normal direction. Or if it's the opposite direction, because if negative, suddenly change direction. So you say in the opposite direction. So once again, a reminder, you define the signs. Your plus, your minus, you choose. The sign is the direction. Oftentimes, we choose to the right as positive, whatever to the left as negative. So it's just telling you negative or positive. Alright, let's look at one or two quick examples of how you can apply all this description. Okay, if your brain hang, you pause the video, you go and look at it and try to internalize how to describe the graph. Don't say, oh, it increased like that. Okay, what is like that? You will need to write it out in this question. So here you have a variation, velocity of a car. Stage 1 is like that, stage 2 like that. So at stage 1, driver see obstacle in the road. But then a short time later, the driver apply the brake. Why got delay? Human reaction time. I see the thing there, I haven't stepped on the brake yet. So steady and then decrease. Describe the velocity in stage 1 and stage 2. Okay, this is the moment we have been waiting for. Stage 1, flat. Then how you talk about it? You can say, since we are talking about velocity, you say velocity is flat, constant. Constant at what? How many meters per second? 18, I think. 18 meter per second. Steady all the way. Then stage 2, what happened? Oh, now decreasing already. Decrease from 18 all the way down to 0. Brake! So we can say that velocity, you see the number go from 18 to 0. So you say first decreasing. But wait, at what rate? Curve? No, straight line. But don't say straight line. Say decreasing at a constant rate. There. This is how we can best explain, okay? So the first one, if you got, say, velocity is constant, that's B1. Second one, you say decreasing at constant rate, then that is another mark. So you make sure you talk about this. Did the graph go into the negative part? No, we are all still in the positive region of the graph. So no change in direction, no need to mention. What example with a change in direction? This is another one. We're going to take a quick snippet look at this. The variation with time t of the velocity of a ball is shown in figure 2.1. Look at this. Boing, boing. Ooh, this one is a bit more tricky already. The ball moves in a straight line from point P. The mass of the ball is 400. Use the figure 2.1 to describe the velocity. What are we describing? Keywords here. Describe, whenever you see this, it means they want you to tell a story. What happened first, and then what happened, and then what happened next. Describing velocity. Is this a graph of velocity? Yes. Okay. We need to break this down into some sections. Stage 1 to stage 2, stage 3, stage 4, or whatever. Stage 1, I am going to call it this one, stage 1. Stage 2, I'm going to do it this part, but I'm going to stop when we go to 0. Because, oh my, this first part of the graph is in positive. After stage 2, suddenly you go in the negative. Oh, so got change in direction. Remember? The sign is direction. So now you go backwards, opposite direction. Notes to self. So we're going to separate this and call this stage 3. Okay, how to describe stage 1? Increase, right? From 0, go up to 5. At a constant rate. So stage 1. We gotta say the time, we cannot say stage 1, we say the time. So from 0 to 8 seconds, the ball has an increasing velocity. Or you can say the ball's velocity increases at a constant rate. That is number 1. I'm going to put a little marker here. Then stage 2. What happens next? Okay, maybe we write down there, next line. You see the value, it decreased, right? From 5, it dropped down to 0. So you can say from 8 seconds to, when did it drop to 0? 10 seconds. The ball velocity now decrease or go down, so decreases. At what rate? Straight line, so we say straight line. At a constant rate. Then stops. I guess we could mention that also. Then stops. The last part. Beware. We are now in the negative direction. Negative part of the graph. So, is it increasing or decreasing? Look carefully. You see this graph? We start where? Part 3. You start at 0. And then you slowly get faster and faster and faster until negative 15. But the negative just tell you in the opposite direction. So number 3, we're going to say from 10 seconds onward, okay, the ball velocity increases, get faster and faster. If you want to specify, you can say increase from 0 to 15 meter per second at a constant rate, just in case lah. Increase the constant rate. Oh, must mention opposite direction. Okay, so you say increase the constant rate in the opposite direction. Man, this was a hard explanation. Got different sections. So if you want to mark this out, the first mark will come from increase constant rate. So this is what we call a B1 mark. Then from part 2 and 3, the mark scheme actually combines them both. But if you say velocity decreases and then velocity increases, can also. An alternative, which we will learn a little bit more later, is these alternative, they look at the graph and they say, part 2 and 3, throughout this entire thing, the gradient is just negative. So here they say gradient is negative. Gradient is what? Acceleration. Oh, so acceleration is negative. So if acceleration is negative, that means we can talk about that in that form as well. Constant deceleration. This is a term that we'll say. Constant deceleration from 8 to 16 seconds. But I wouldn't recommend you use this. Better if you describe section by section how the velocity change, okay? I think that's all. The main section of practicing how to describe a graph. Now know your description words, because coming up next, we are going to look at how do you translate a real life scenario into a graph and link together all the graphs of velocity, acceleration and displacement in terms of mathematics. So gradient, dy, dx and area under the graph. Okay, so see you in the next video.